I want to share with you guys report NVIDIA released this week about Vera Rubin performance. And my goal with this small talk is to explain this report to you. And I hope that you can understand it. Benchmarking and performance analysis sometimes is hard to understand and to get what the results are. So I'll do my best to explain it so you can see why NVIDIA is going to put a lot of pressure into CPU-centric companies because they are doing extreme co-design, and I will explain what is the meaning of that and the influence it will have in hyperscalers like Microsoft, AWS, Google, and others. You have to remember that hyperscalers are decision makers for many small companies because they keep the trend. What NVIDIA has developed is a whole horizontal and vertical integration to enable the best performance possible for AI, specifically for agentic AI. So we are going to try to understand this report, and together we will try to see what is the meaning of that, of what we are seeing right here. So let's start with the title. So they say that up to 30x more work per watt, NVIDIA Vera Rubin sets a new efficiency standard for AI agents. Okay. Based on what they say, they are claiming that you can get 30x higher throughput per watt and 30x lower tokens cost than the previous product. The meaning of this is that you are getting a lot of more work, but you are paying less. An analogy of this: many companies hire people in other countries because it's cheaper and they can do a lot more work in a lower price. It's the same concept, but with tokens, which is good because you want to have higher throughput and you want to pay less for it as a hyperscaler, so you can have a higher margin of gain when your end users in the cloud use this type of systems. So this is good. Remember that NVIDIA a while ago presented something called AI factories, and I have created some content on that the AI factories are the future of artificial intelligence, and the fact that it's high extreme co-design across the whole thing, not only the GPU. This is something that you need to get. The extreme co-design is the optimization of the whole infrastructure. That's why it's called AI factory. It's an optimization of the whole factory. So if you see this, then companies like Intel, AMD, or ARM will have a lot of pressure on their products because people, of course, want to buy a full solution, and also NVIDIA is the leading one on the ecosystem at the moment. Why would you buy, let's say, heterogeneous systems when you can have homogeneous systems and get the gain of extreme co-design and optimizations across the different versions of code they are delivering? It's an easy decision to do. And I think companies like Intel and others have not understand this, but they will soon see it, believe me, because this is going to be the standard across the industry. Something to remark is that AI agentic workloads consume 15x more tokens than just a simple chat. And you may ask yourself, why is this? What is the reason of this? And it is because in agentic AI, you have to make sure you can enable long context handling, because this is what affects the agentic performance. To explain what long context mean is that, for example, here on this image, we have, it says inside an agentic workflow for investment research. So basically, this is an agent that is going to do investment research, and there is a workload. There is a main agent that will do the planning. Then you have sub agents that will use tools to accomplish this goal. Maybe the first one will do a query on Bloomberg, then the second one will do a search in the news, and so forth. But the most important thing here is that for every subagent, as the plan goes on, the context, the result of that needs to be sent to the next one, to the next in the process. So whatever the first subagent found, the query Bloomberg has to pass it to the next one. And as you can see, you have here a long context handling for the agentic performance. That's a key differentiator to what we previously have. So that is why it's very important that whatever infrastructure you have in the bottom enables you to do this type of long context handling, because it's key for the performance of the agents. And this is something that NVIDIA is proposing as their value proposition. As they say here, as agentic AI moves into production across industries, the infrastructure running it needs to meet the token demand efficiency. Whatever infrastructure you run under AI factories for NVIDIA, it need to have token demand efficiency. Because why? Because you have to do long context handling. If you don't have a good infrastructure, your AI performance is gonna be hurt. Something to remark also is what they are saying here. They are getting good performance, but still they can do a lot of more software optimizations, performance across both ones, the Beta Rubins and the GB300, to continue to improve whatever they have shown on this report this week. And why they can do this? Because they did extreme co-design. That is the key to understand. So also something to remark is that if you have a basic inference, you may consume 1K to 8K tokens. But as they say here, performance measurements must evolve to capture the full agent workflow than rather a single inference request. Agentic AI is a very powerful technology, limitless almost in the digital world of what it can do. But if you see this chart in the left, you have traditional inference. Basically, you will have an input, then you will have a model, and then you will have an output. The input sequence length sometimes go from 1K to 8K to 32K. And you can have predictable IO, you can have single requests, you don't do any tool cooling, static hardware tuning. But agentic AI is a whole different flow of execution. It's very unpredictable. That's why what they are saying here, benchmarking has to evolve. Benchmarking have to represent what agentic AI will do in real life. Because with agentic, you have a task. Yes, you will have an agent, and depends on the architecture of the agent that you choose. You can have multiple agents, or you can have one agent. You can have one agent that controls many agents. And these agents will call tools, and they will have environments, and they will work together in order to produce a result. So their input sequence length is higher, 32K, 100K, 400K. And I believe this is going to keep going up higher and higher and higher. And something that is remarkable to mention is that you have dynamic sequences. It's not a static one. It's very dynamic, can fluctuate. You can do multiple runs of it. You have tool cooling. You need to do end-to-end tasks. It's not a traditional inference. If we go to the app visualization, you can see these agents that are working here, the main agent and sub agents. All of them are working together and all of them are calling tools to do their work. But they are working end to end. And the results are not static from one sub agent to the planet to the next. It can vary a lot. And you can do multiplex execution of this because you can even have agents that do verification of whatever you are doing. So you start to see how all these things tie together to each other. Long context handling is important to agentic AI performance. And also the token demand efficiency is very important. And the thing they mentioned here, the software optimization, the performance across both products, as they say, will continue to improve because again, they have extreme code design into their infrastructure. They are also saying that agentic AI needs a new set of benchmarks that represent the truth work in the real world in order to optimize and create new improvements and innovations. Because agents, what they do, you have to remember, they simulate what a human will do. But they need to be able to do all these things. It's very stochastic, undeterministic. It's a wonderful technology also. They also claim that the NVIDIA Blackwell performed very well on different models, like LLM models. Even their previous product, the GB300, offered 15x better performance per watt. If we see the charts, I'll try to explain the charts. Basically, you have the throughput per megawatt, transactions per second per megawatt. On the y-axis, and on the x-axis, you have the interactivity, transactions per second per user. So you can see in their previous product, the GB300, their performance in the low interactivity of the users was higher, but as you start to have higher interactivity or transactions per second per user, you start to see a drop. But with the Vera Rubin, the new technology they just released, you can see they mentioned these are ratios, by the way, ratios, mathematical ratios, 2x, 10x, 30x. Even in the previous product, you see there is a huge drop. The Vera Rubin keeps up and then it starts to degrade. 30x improvement performance for the Vera Rubin compared to the GB300. So you may ask yourself, what is this? What can I do with this? It has a lot of implications. It means that you can have higher interactivity. You can run more complex AI workloads, agentic AI workloads. That's the interactivity, as what Jensen Huang mentioned about the interactivity is the complexity of the task you are doing at a specific second, at a specific time. So basically, this chart is showing us that this new product, the jump is very significant in the performance with previous one. Remarkable. Something very important that I just mentioned is the extreme co-design. This technology for NVIDIA just manage the power across, look at this, GPU rack workload levels to provision up to 40% more GPUs within the same megawatt budget. The meaning of this is that if you had, let's say, a constraint of 100 megawatts, without this technology, maybe you can have, let's say, 50 GPUs. But with this performance, you can have 40 percentage more GPUs. So you will have more GPUs for the same amount of megawatts because it's extreme co-design. So imagine that you are not only getting higher throughput performance at a lower cost, but also for the same megawatts, you can add more GPUs into your infrastructure. You can see this other report about the cost per million tokens interactivity, still 35x lower in the cost using Vera Rubin. Like I mentioned, extreme co-design for agentic scale. And I think this is one of the most important things about what NVIDIA is doing with their AI factories and all their technologies is that they are seeing it as a complete system solution working as a whole, as let's say as the body of the human being. One AI factory is a body of a human. It has multiple parts and they can be all optimized. For example, if you eat a lot and you don't do exercise, you get fat, right? But if you do exercise, then you get fit because it's one system, one biological system. It's easier to do optimizations on one biological system. Same with this approach of extreme co-design because you are not seeing just servers here, you are seeing a whole infrastructure, an AI factory where you have extreme co-design at all the levels, not only in the GPU stack or the hardware stack, but the power stack, the rack stack, the server stack, the whole thing integrated into optimization that they can deliver. How do you compete against this if you are a company like the CPU-centric ones? This is a good question. I think we are going to start to see the results of this very soon. Microsoft this week just mentioned that they received their first servers, and I do believe the whole infrastructure of cloud providers, hyperscalers, will switch into this type of technology. So I think for the next video, I will deeply engage on the extreme co-design for agentic scale. I will explain these different methods of modern inference optimizations techniques. We can try to understand this together because this is the standard across the industry. And if you are working on AI, you have to understand these optimizations and technologies in order to provide the best customer experience and create the best product that can compete and win on this endless war for influence, status, and money. See you in the next video.